Hi girls, let me continue with you the previous lesson. Yesterday we have been discussed about factoring a special case. So we started with the perfect square, and we said that if we have something like this, we call it perfect square, which is this one. Let me write for you down. So that is perfect square. So that is perfect square. So the perfect square, which is will be a plus b, all this to the power 2. So that is will be equals to a to the power 2 plus 2ab plus b to the powers 2. If you remember what I told you, it is looks like song. You can say the first term squared, the last term squared, 2 times the first and the second term. So 2 times the first and the second term. This is exactly the same idea if you have here negative, and the only change will be here also negative. So we discussed about this yesterday, how we factored this trinomial into back to this one. We said before, if we have a plus b and we have times a plus b, which is exactly the same as a plus b squared, we said multiply special case. That's what we said, multiply a special case of the polynomials. We said in the previous lesson and in the beginning of the lessons that we learned in this chapter. But today the opposite, because we have this, we will go back to this one. So we are going to say it is factoring. So today we are going to talk about difference of two squares. So difference of two squares, which is this rule. Once I giving you, before I gave you a plus b and a minus b. So you have exactly the same two terms, but the only different in the sign, not like this one. So here you can say it is a to the power 2, the first term squared, minus always the last term squared. So that's what we learned before from how to move from this one to this one. Today, we are going to do the opposite. I will give you this one, and you will directly write this one, and you will gonna say we will have a special name for this rule or for this property, what we call it, difference of two squares. So that's the difference of two squares. Let me move with you and start explain for you example 3. We finished the first 3 problems with their exercises. So this is the difference of two squares that I wasn't talking about. Let me give it to you in details with exercises, because I don't want to repeat it. It's already here. This one, you can, if you have, for example, x to the power 2 minus 64, you can directly say that is x corresponding to a. B, you can change this one into 8 to the power 2. Now you have everything exactly the same as this rule. Just rewrite it, x minus 8 and x plus 8. If you have something like this, you can just say here, you can change this one into 5x, all this to the power 2 minus 6 to the power 2. So you have everything. You have the a is this one, you have the a is 6, so you can say 5x minus x minus 6 and 5x plus 6. Let me give you this example. So here we have same idea. I'm going to say that is z to the power 2 minus 3 to the power 2. So that is equals to, directly according to the rule that I just wrote, which is the difference of the two squares. Since here, make sure that you have here minus. If you have a plus, you cannot do it. So that will be z plus 3, z minus 3. You're done. moving. Exactly the same answer. If you want to check your answer, you can multiply them again, then you will get go back, you will get the same as this result. If you see the multiplication here, they checked, once you multiply them, you will cancel this one with this one, so you will get finally exactly the same thing that you have. Here is same thing. I will change this one into square, so I can v to the power 2 minus 10 to the power 2. So I can say that is equals to, which is corresponding to what I have. So I will say v minus 10, v plus 10. Why I'm doing that? Again, I would like to remind you, a minus a squared minus b squared, that is equals to a minus b, a plus b. You're supposed to memorize this from the before I gave it to you. This is extra. So here is same thing. I can say that is s to the power 2 minus 4. So I can 4 to the power 2. Now I have a difference of two squares. This is square and this is square. Difference between two squares. So I can say that is s minus 4, s plus 4. Let me continue. Here exactly the same idea, but the only difference that I have here, I have a coefficient. So let me fix this coefficient so I can have this one also squared. So I can write 4x all this to the power 2, because if I distribute, I will have 4 to the power 2, and I have x to the power 2, which is exactly the same as this one, minus 9 to the power 2. I have difference of two squares. Now I can say 4x minus 9 times 4x plus 9. Let me give you more practice. This one will be 5d to the power 2. I can say all this to power 2 minus 8 to the power 2. So that is equals to, according to difference between two squares. So 5d minus 8. Keep in your mind, you should not write d 64 or 25 like that. No, you will write the base. So just write the bases, 5d plus 8. All right, now the question, this is the answer for A. Now they are telling you, if you have this one, contains two perfect squares, can you use the method here? Can you use the same as this one? No. The answer I will tell you, no, because you have here addition. You cannot use this rule. It is from this rule tells you difference. It is, I'm telling you, it is difference to the two squares, the difference of two squares. So you cannot use it. So the answer is no, you cannot use this one. You cannot use it because you cannot say is not a difference of two squares, because this one 25, it is not a difference between two squares. The last problem that I have in this lesson, exactly the same idea, but the only new thing that I have here, it is just factoring one from this number. I cannot have here perfect square root, right? But I can see here there is common factor between them. So let me find this common factor between them. I can see immediately 6 between them. This one, I can factor it out 6 times. 6 times what? 6 times 4 will give me 24. While this one, I can say it is 6 times 1. So I can take out or factor out the 6. So I will have 6, and then inside 4g to the power 2 minus, sorry, that is minus. It is here, these. Yeah, minus 1. Because I took this outside, so minus 1. Now I can rewrite this one into 2g all this to the power 2 minus 1 to the power 2. 1 does not change. Outside is 6. Can you work on that? Yes. This is difference between two perfect square. Directly, just say that is equals to, use the rule that you learned before, leave the 6 outside, 2g minus 1 times 2g plus 1. So that's the answer only. Let me move to the next exercise. Here I have 12t squared minus 4. So what, minus 48. What is the common difference between them? So I can tell you a 12 itself here is its common difference between them. So if I take a 12 outside, so the remaining inside t squared minus 4. Definitely, if you are sitting alone, you just need to sit and think about them, just maybe little time, not long time. So you can just factor it out if you want. You can factor the 48 into factorization. So, but I don't think that you need to this one. So now I know what is this. So 12t squared minus 2 to the power 2. Excellent. I have difference between two perfect square. So just use your rule. T minus 2, t plus 2. Let's see the next one. Here we need to work and use the same thing that we did yesterday. First of all, let me see what is the common between them. Can I say 12? No, because this is a 3, so I cannot say it. So let me take 3 outside. The remaining is, since 12 is 3 times 4, so the remaining is 4x to the power 2 plus 4x plus 1, right? Now I can say that this will be 3 times. Can I play with this one? So I can say this is a raised to, so x to the power 2. Did I do anything? No, I did not change anything. If I wrote this one into 2 to the power 2, which is 4, I will have 2 to the power 2. I will have x to the power 2. So overall, 2x, all of this, to the power 2. That's why I wrote this. Now, can I say that is 2 times 2x? Yes, plus 1. Can I say that? Which is here means here I can say times 1. Can I do that? Yes. Did you remember the rule that we just said, the perfect square? So we can say a plus b, all this to the power 2 if I have the first term squared, the last term squared, 2 times the first times the second, 2 times the first, the first term times the second term. That's what I have exactly here. I will leave my 3 outside, but I can say directly 2x plus 1, all this to the power 2. That's the answer. If you don't feel that this will convince you, you can just rewrite it, this one, into 2x plus 1 times 2x plus 1, multiply them together, then multiply them, distribute the 3, then you will get exactly the same as this one. Let me give you more related exercises. So here, from these exercises, I want to solve with you exercise 30. So exercise 30, which is exactly the same idea, I'm going to write this one into 2p to the power, all this to the power 2, which is the same explanation that I did before a few minutes, minus 7 to the power 2. Make sure that you have negative. Yes, that's good. So it's difference between two perfect square. So that is mean 2 p, according to my rule, 2p minus 7, 2p plus 7. That's it. You're done. Now let's do more exercise. Let me do with you 32. So I can say that is equals to 6v all this to the power 2 minus 5 to the power 2. All right. So that is equals to 6v minus 5, 6v plus 5. That's it. And the rest exactly same idea. Let me tell you here. Rewrite the expressions so the difference of the square, then factor them. Here, you don't need to worry about this shape. No, you can say x to the power 2, all this to the power 2, minus y to the power 2, all this to the power 2. Any problem here? No problem. I just have difference between two perfect square. So I will say 2 minus y squared. Then I will say x plus y. I forgot to write the squared here. Now you can do this one more, right? So, but this one you cannot because it's addition here. So use your rule again. X minus y, x plus y. So that is times x squared plus y squared. That's the idea. Use just all this lesson just using this rule, which is a minus b, a plus b. That's what I'm using in all my exercises. I'm trying to making them something raised to power 2, and then I will deal with it as a, and I will have same thing here, something raised to power 2, and then I will deal with it with b. So once it will be negative, and the other time it will be positive. If I have something like this, I cannot definitely factor it more. So I already have more exercises, but I did not put them in my PowerPoint. So first of all, let's see exercise 54, which is in your book, exercise 54. Exercise 54, it tells you 108 n to the power 6 minus 147. The question is factor. The only thing that you know, before a few minutes, I told you about this rule. A squared minus b squared equal the rest. But here, what should we do to do that? So I'll try to find the common factor between these two numbers. Then I will try to take it out because these are not perfect square. I cannot play with them. So after you try to find the greatest, I'm not trying, girls, to find in your level, to find for you the greatest common factors between numbers, because I'm pretty sure 100% you know how to find the greatest common factor between them. All right, let me tell you, the greatest common factor between them, this number will be the greatest common factor between them, 3 times 36, and this one is 3 times 49. Times 49. All right, so if you take outside this 3, if you pull it out, if you take it as a common factor, 3, so the remaining here, 36 n to the power 6 minus 49. So you can rewrite this one. This is easy. You know that 36, it is 6 to the power 2, right? So you can say that is 6 to the power 2. You can also write this n into, you can say it is 3 all this to the power 2, right? You can say that. Now minus 7 to the power 2. I did more steps here to show you. Can I raise all these two numbers to power 2? Yes. So I will take, it is like the opposite direction from things that we learned in chapter 7. So that is to the power 3. All this to the power 2 minus 7 to the power 2. Great. Now I have a difference between two perfect square. That is difference between two perfect square. So I would like directly to say, okay, that is a 3 inside 6n to the power 3, once minus 7, and once plus 7. So 6n to the power 3 plus 7. That's it. I also have one more exercise for you, which is the exercise, which is exercise 54 also. Not exercise 54, that is exercise 54. Exercise 55, sorry. So exercise 55 will tells you. So exercise 55 will tells you it is x to the power 20 minus 4x to the power 10 y to the power 5 plus 4y to the power 10. So directly your mind will go to the perfect squares. So your mind will go to this formula. All this to the power 2, which is equals first term squared, last term squared, 2 times first times second, minus 2, because I have minus here. 2 times first minus second. But what should I do if I have this? What is this? Power 20. I can again play with power raised to another power. I will say it is power 10. All this to the power 2. Second thing I will say, 2 times 2x to the power 10, y to the power 5. Here I can rewrite this one also. I can say 2 to the power 2, y to the power 5, all the y, this y to the power 2. Then I will rewrite this part again, and I will reorder this one. I need the x alone. So I will have x to the power 10, all this to power 2, minus 2, x to the power 10. I'll change the order. I will write times 2y to the power 5. Why I'm doing that? Because I need it here. So that is a plus 2y 5, all this to power 2. Do I have exactly the same as this form? Yes, exactly. That is here. That is A, which is this 10 will be your A. So that is your A. Let me just change the color. I want you notice what I'm doing. So that is your A. That is your A, exactly same if you look at it. Then let me change also the color to show you. That is B. That is B. Look, B raised to power 2, which is this one. Then x is raised also to power 2, which is this one. And there is negative 2, which is exactly the same as this form. Now let's directly write this one. X to the power 10, since we have minus in the middle, so we are going to say minus. 2y to the power 5. All this to power 2. If you would like to write it, x to the power 10 minus 2y to the power 5 times, it is instead of repeating these two parentheses, you want to write this, or it's okay if you write like this, you want to repeat them, No problem. Remember, they have exactly the same two binomial because these two terms, it is binomials. So that's for my lesson. Don't forget, girls, you have homework. You have homework this lesson, homework 887. So you have homework 8-7. Don't forget to submit the homework for 8-7 tomorrow. Good luck, girls. Bye.